In the last class, we saw the usage of the equation F is equal to ma. Now, we will look at this equation in a new form, and this formulation is referred to as the work and kinetic energy formulation, which leads to the principle of conservation of energy. So, in order to see this, let us introduce two new concepts. We will introduce the concept of work and the concept of kinetic energy. So, these are two terms which will be defined in the sense of physics in today's class. So, first we define the term work, and when we talk of work, we talk of work done by a force. So, we have a particle or a body on which a force acts, and in general, if this is the only force acting on this body, then the body will start to move with an acceleration a in the direction of the force. Of course, more than one forces could be acting on a body. Now, what we are going to do is, let us define the term work done by a force. And what happens is, to define work done by a force, we need two things. Firstly, we need to know the force, which we know is a vector, and then what we know is, if what we also need is, if the if due to the action of this force the body undergoes a displacement d. And what we will do is, let us start this in a simple sense by looking at the one dimensional case first. So, we start with a one dimensional case, and so that we have a particle, a force F is applied, and because of this the particle undergoes a displacement d. So, we define the work done as the product of the force and the displacement d. So, in this case, when a particle undergoes, so we are talking of a 1D case, so force is in this direction, and because of this the particle moves a distance d in the same direction. So, the work done by this force is defined as F times d. So, this is the definition of work done by a force. So, which means that to be able to define work done, we need two quantities. We need the force which is acting, and this will be work done by this force, and the effective displacement of the body which it undergoes while this force is acting on this. So, that will be called the work done by force F. So, work done by force F is the product of the magnitude of force and the magnitude of displacement, and this we should say this is for a one dimensional case. We will generalize this to a two dimensional case slightly later. So, now let us talk in terms of vectors. So, we have a force F which is acting, because of which particle undergoes. So, this is the particle which I am showing as a dot, it undergoes a displacement r. So, therefore, for the 1D case, work done will be equal to magnitude of F times magnitude of r. Now, it can so happen that n forces can act on the body simultaneously. So, let us say we have a body on which, so we have a force F1, a force F2 and so on. So, different forces act on the same body. So, now we will have work done by F1, work done by F2 and so on. So, each force will do a work on the body and the work done will be given by the product of force times the displacement. Now, let us generalize this concept. We talked of a 1D case and we generalize this, and in a general case, let us say we have this particle on which the force F is acting, and particle, let us say there may be more forces acting. So, therefore, we are looking at the work done by this particular force, let us say F1. Now, if the particle is moving like this, let the displacement of the particle be given by r, and so the angle between the force F and the displacement